putting us on our way to Jupiter.
Thank you, James. And now we'll hear from Kaylin Benura from Pine Ridge High School in Deltona, Florida. She's a participant in the Goldstone Apple Valley Radio Telescope Project. So, Kaylin, please.
Thank you very much. My school has been participating in GAVRT since May of 2006. Typically, we have three to four 2-hour sessions per school year, but it really varies depending on what sort of window of opportunity we have, where the planets are, and it just depends. During our GAVRT meetings, we're remotely connected to the Goldstone Apple Valley Radio Telescope. There are actually 3 dishes, but typically we are connected to the DSS-12 or the DSS-13, which is one of the 500-ton deep space telescopes at the NASA Goldstone Complex. Using these telescopes, we're able to gather data from Jupiter, and these radio waves we collect actually result from the interaction of the high-energy electrons confined within Jupiter's magnetic field line. The data we collect with the GAVRT telescope could prove to be pretty vital to the JUNO mission because it can, as you saw earlier on one of the radiation charts, it can start to image what sort of different waves could be damaging to potential spacecraft such as the JUNO that are going out there. Typically, our main targets during a run are quasars and Jupiter. Each scan is essentially 2-part. We have one in the declination direction. We also have one in the right ascension direction. Once the telescope begins its scan, we start to call numbers and record the baseline or background readings. Once we've had enough to really establish a background power reading, we can begin to watch the power levels rise. This will allow us to start to see peaks in the energy, which these occur when the telescope passes over the face of, say, a planet. And these peaks are usually pretty concise, so it takes several of us to get this done efficiently. We typically work as a group. We have several people who help. We have people calling numbers, we have people spotting numbers, and we have people recording them all at the same time. After we can catalog the peak, we also have to record the baseline out so that we can establish that there was a peak there. Overall, there's a lot of other data we look at, but peak and baseline readings are essentially what we study. This has been my first year with GAVRT, but it's truly been an experience to remember. I've learned so much, and not necessarily only about, radio analysis, but that science is so much more than just about, math, experimentation, and observation. It's about collaboration, it's about teamwork and cooperation. When we gather information with the GAVRT telescopes, we have to work as a group because, as I said, we have numbers coming in all the time and peaks are really quick. So in order to efficiently spot the clandestine peaks and fluctuations, we really have to work together. It's been a great program too because it's your first real taste of professional science, your first real taste at getting your hands, dirty, getting really involved with it. And I truly valued it, and I think the other people I worked with this year have grown not only as people but as scientists and aspiring astronomers, and it's really been great. It's allowed us to see past what we can just see, with our eyes, and we can see things that not everyday people get to see, and we get to start exploring the depths of space, and it's really been great, and it was a privilege to be part of it, and I would recommend it to any upcoming astronomers. It's just great. It really is.
Thank you, Kaylin. We're ready now to take questions, so please give your name and affiliation first when the microphone comes to you, and we'll start right here in the front with Marcia.